You are watching iSpy, a behind-the-scenes look at what's cool and innovative in the world of manufacturing today. This is Jake Ervin with IMTSTV. For this edition of iSpy, we've traveled out to Mishawaka, Indiana, and we're at Penn High School to talk to students and teachers about manufacturing technology. As you can see behind me, we brought the IMTS Rally Fighter with us. It was a pretty tight squeeze to get it through the hallways, but with the help of about 20 students, we were able to squeeze it through. And as you can see, they're super excited we brought it with us. And that's what it's all about, to get teachers, parents, and educators excited about the opportunities available in the manufacturing technology industry. Right now, we're in the robotics classroom in the manufacturing center here at the STEM Academy. Today, we're speaking with Jim Langfeld, and he's a robotics professor here at Penn. Jim, how's it going?
Super. Welcome.
Great. Thanks a lot. Thanks for taking the time to speak with us today.
All right.
Now, can you tell us a little bit about the robotics curriculum here at Penn?
Sure. So since 1998, Penn Robotics has been a part of FIRST competition. FIRST is for inspiration and recognition of science and technology. Every January we get a challenge, and this year's challenge is called Ultimate Ascent. We are given two primary focuses. The first focus is to take frisbees and shoot them into scoring positions, and the second primary goal is to get robots to climb this steel structure.
That's awesome. So the competition is actually part of the curriculum.
That's correct. So our robotics class at Penn High School focuses two primary things. The first focus is community outreach and business. We have about a $70,000 budget that we have to raise. And then in January, when we receive our kit of parts, everything turns mechanical and design, and we go about designing and building a competition robot.
And that's what we're standing in front of here. This is the competition robot.
Yeah, so what we see right here is 4 weeks of design and prototype. So if you were to come back 2 weeks from now, you would see a finished machine completely made out of aluminum, welded by students, machined by students, programmed by students, ready to go to competition.
Well, thanks a lot for taking the time to speak with us today, Jim.
You're welcome. Thanks for being here.
Yeah, we really appreciate it. Now let's take a look at how the process all comes together. The design, the building, and then we'll see how the machine actually works. Before you build the robot, you have to design it. So today, we're here with David. He's a senior at Penn, and he's in the robotics class. How's it going, David?
Pretty good.
Great, man. Can you tell us what you're working on here today?
Yep. This is the integrated model for the robot. This contains 3 of the 4 separate subsystems. Down here we have the drivetrain, which includes the frame, our locomotion, which are 3 wheels powered by sim motors, and our bumpers. This tower structure right here is our disc collection, which is how we're going to get the discs from the floor into the shooter, which rests right up here.
So a lot of time goes into planning before you actually design.
Yep, because once you get a plan done, it's easy to work out everything in the design process, but if you just go straight into the manufacturing, then you're going to be spending a lot of time wasting material, because then you're going to have a structure that's not going to work, and if you just sat in here and did the CAD model, you could clearly see that that's not going to work. Instead, if you go out there once again and you build it, and then you realize after you built it it's not going to work, then you've just wasted all that material that you could have used on that actual robot.
So that was the first step in the process, the design. Now we're going to go see how they actually build the robot and integrate the design with the manufacturing. This is where the design meets the metal. We're here in the Fabrication lab at Penn High School with junior Alex talking to us about how they actually built the design for the Ultimate Ascent robot. Can you tell us a little bit about how you took the design and actually made it into something real?
Yeah, what we kind of did was we have our design team in the lab, and they give us a technical print of all the measurements and all the parts that we need. We go right back over in that corner, and there is an aluminum shed back there. So we pull the stock we need, and we cut our components and put them together back here.
That's cool. It looks like there's a lot of different welds on this machine. Did you guys do the welding yourself?
Yep, I do that, and a friend of mine, his name is Kyle, does that also. And we do aluminum and steel TIG welding.
All right, so what are we looking at here?
We're looking at the base for our drivetrain. This is all aircraft aluminum. We get the aluminum donated to us, and we cut our components and put them together for you.
So you guys had some pretty strict tolerances that you had to meet in the manufacturing of this machine.
Yeah, the machine has to be 120 pounds, not counting the battery and the bumpers that go on it. And I believe it has to have an exact perimeter of 52 inches. So this machine is a 24 by 30 inch machine.
So now that we've taken a look at the design process and seen how the machine actually gets built, how in the world did they get it to throw a Frisbee? Brian, can you give us some inside scoop on how you actually brought the machine to life?
Sure, Jake. We start off with a hand sketch of the robot when it's still in the initial design phase, and we start looking through every action we might want the robot to perform and figuring out what the robot needs to know in order to complete the action, and then what the robot will be doing with that action. From there, we get a list of motors and sensors the robot will need to be able to do its job, and a list of controls the driver will need to be able to tell the robot what to do. From there, it's many hours of writing computer code, soldering and wiring control harnesses, and the most interesting part of the job is how at any moment a design change or a manufacturing problem on the robot could completely change everything we've been doing. So it really keeps you on your toes.
Okay, so the challenge is called Ultimate Ascent. I get the ultimate part, I play a little disc myself, but what about the Ascent?
Well, there's 2 metal towers on the field, and at the end of the game, teams will be literally having the robots climb the tower to try to get extra points.
And how high is this tower?
The top bar of the tower is 93 inches, so the robots will be anywhere from just barely off the ground up to 90 inches in the air.
Because, I mean, I could throw a Frisbee in there pretty easy. Right. You know, I'm pretty good.
Right.
Yeah.
Well, you have the benefit of eyes and judgment. To give those same things to a robot, we have these little $35 computer boards called Raspberry Pis.
Nice.
There'll be 2 of them mounted on the robot, and their only job is going to be to look at that gray tape surrounding those goals and help the robot figure out where it needs to throw the Frisbees. This gray tape's really special because it looks kind of dull to you now, but it reflects light in a very particular way. Instead of out at a same angle like a mirror would, it reflects it straight back wherever it came from. So we'll take an LED light, and if we point that straight at the tape, the robot, it lights up for the robot clear as day, but not for anyone else. And we'll be using this along with a webcam mounted to the Raspberry Pis to help the robot find its distance and angle to the target. And then it will be able to know how fast and high to shoot the Frisbee to make it in. And that's something your brain does naturally, but it's very difficult for a robot.
I'm here with my friend Preston, and he's going to go ahead and fire up the machine, and we're going to play a little disc.
Hold up, Jake. Robots can be dangerous. Why don't you take these safety glasses?
Thanks, Preston.
No problem. Another cool thing about this robot is that we're actually able to store discs up here, so we can use rapid fire. So if you guys want to see that.
Yeah, I think I might huck a little disc with the robot. What do you say?
Yeah, let's do it.
All right. Well, the proof's in the pudding. That disc just fired at a really high velocity at the wall behind us and almost hit its target. There's a few tweaks that still need to go on, but the competition's coming up, and after talking to these kids, I'm confident they have what it takes to meet the Ultimate Ascent Challenge. Thanks for watching iSpy. I'm Jake Ervin for IMTS TV, powered by AMT.